Welcome to Toronto Machine Learning Micro Summit in Retail. My name is Nadia, and I work at Nalias as a senior machine learning engineer. Today, I'm honored to be here and to have the opportunity to introduce two of our amazing speakers. Before starting, I would like to remind you that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speakers after the presentation. So our speakers of today are Kanchana, Padmanabhan, and Tian. Kanchana is the Director of Data Science at Kinaxis Inc. and lectured in the Data Science program at Ryerson University. At Kinaxis, she leads the ML Applied Research team that focus on R&D of machine learning solutions for enterprise supply chain problems. At Ryerson, she develops and teaches courses at the Yeats School of Graduate Studies and the Chang School of Continuing Education. She has developed multiple courses in the area of big data tools, graph mining, deep learning, machine learning, and data visualization. She is also an advisor to students in Ryerson for their final research project. Kanchana earned her PhD and master degree in computer science from North Carolina State University in the US, and her bachelor degrees in information technology from the Madras Institute of Technology in India. Tian Chen is an advisor ML developer with the applied research team at Kinaxis Inc. He is interested in retail demand forecasting and partially observed time series and arrival processes. He earned his master's degree in statistics from University of Toronto. Please join me in welcoming Kanchana and Tian.
Thank you, Nadia. Thanks so much for the opportunity. And I look forward to hearing all your questions, but maybe let me just jump right into the presentation for now. So thanks everyone for joining. We're very excited, Tim and me, to be presenting this particular topic, specifically because it's been kind of a very interesting issue that we've had to face in our ML solutioning, and the solution for this is kind of interesting. So, all right, let's jump right in. You already know who we are, so I'm not going to spend time here. So the agenda we'll have for today is the following. So I'm going to give you a little bit of an intro on who we are, like what's Kinaxis about. And then I'm going to jump right into talking about our use case that actually triggered this particular machine learning problem for us. Then we'll talk about some issues that we faced when building this machine learning solution. And then Tim's going to walk us through in depth about what the solution for this problem can look like. So let's jump right in. So Kinaxis has been in the space of business planning and digital supply chain for many, many years. We've been a leader in the space, and we've been around since 1984, so it's been a long time. We're in more than 75 countries, and to add to that, we are also in many different verticals, starting from aerospace to automotive to consumer products to high-tech electronics to retail to industrial areas and life sciences. And many of the top companies in all of these areas happen to be our clients, so we're very privileged to all of these different industries. A little bit about the machine learning at Kinaxis. So Kinaxis has had a machine learning practice for several years now, and I would like to think that we have a reasonably mature practice. So if you just look at our system itself, it starts with the data, which is obviously, if you think of retail and retail specifically, you can think of how large the data sets can be. Just having transactions per store, per product, promotions, inventory, all of that data is massive. And all of that is ingested and supported by our awesome data platform that pretty much sets us up with a framework to actually manage and handle all of this large-scale data. In addition to this customer data, we also have a very interesting dynamic signals that we work with, like flu, weather, holiday, social media. So we bring that in along with customer data to actually improve our machine learning systems. Apart from the data platform, we also have an MLAS platform, which is machine learning as a service. So that's the platform that helps us scale, orchestrate, and run all of our machine learning jobs and monitor them and make sure that everything is in order with our large-scale machine learning systems. So at the crux of it all, of course, is the machine learning solution itself. And nothing you see on the slide should be surprising to you. We obviously have a very sophisticated feature engineering system. We have a very smart and good training system, which is also distributed. We also have the capability to provide forecasts at many different granularities, many different frequencies. And on top of that, there are certain use cases that we do that also require an optimization engine to be in place. A common problem includes optimizing, say, for example, a flyer, trying to find the best set of promotions you can put on a flyer. So use cases such as those require an optimization engine to also be present. So a combination of all this forms the AI system. And specifically, the machine learning itself is done across two different teams. There's a team in Ottawa, there's a team in Toronto, and we work together in providing machine learning solutions. And just a little bit more about our team. So as much as we are interested in solving problems at scale and providing solutions to the industry, we know that a lot of it stems from doing very good R&D. So we also have a lot of partnerships with different universities, different professors, and we manage to churn out papers as of when we think something's useful and interesting enough to publish. And that also takes us to many different conferences and symposiums to present, and that also leads us to have a lot of patents and grants and a lot of other collaborations. So just a little bit of an overview of what we do. All right, so let's now dive right into the problem itself. So promotional planning in retail is a really important use case. So the question goes like this. So as a category manager, what is the optimal promotion I should run in 6 weeks' time in order to maximize margin, keep sales constant, given a fixed amount of vendor rebates? So let's break this question down a little bit. So first of all, who is a category manager? A category manager is someone who's responsible for the well-being of a certain number of products in a retailer. So each retailer has a different groupings of products, but in general, if you can think of, say, skincare being a category, there'll be 1 or 2 people who are responsible for the well-being of skincare. So they determine what kind of promotion should be run on these products, keeping in mind certain constraints like certain time periods, certain margin constraints, certain sales constraints, and there's possibility that the vendor might only rebate or support certain amount of the promotion, so they have to keep that in mind as well. So the category manager has to keep all of these variables in mind and then kind of decide what promotion to put their different products on. And sometimes they may be responsible for hundreds of products. So the levers that are available to them could be promotion type, discount percentage, flyer location, whether they put a product on a front page or a back page, if they're going to run it for a specific region, say Ontario versus BC, whether they're going to open it up for all customers or whether they're going to open it up for only certain loyalty customers. Are they going to target certain groups like seniors or students? Are they going to run it for everybody? And on top of that, they have constraints like vendor funding, as well as some additional inputs like margin to consider. So they have to do that ever so often. And of course, you can imagine machine learning being something that can be used for a problem like this. In fact, the Gartner's top 10 trends for 2021 states that as the third most popular trend, or the third most important trend, where algorithmic and machine learning is going to be supporting things like what products to promote given certain constraints. So of course, we are in the space of providing a solution for this kind of a problem. We have a really nice promotion scenario planning tool where we do allow the category manager to kind of work with certain of these levers, put certain inputs in, look at what the outputs are, compare different scenarios, and then, and of course, the crux of it all is a machine learning model. And I've oversimplified it here, but I think it's sufficient for the sake of this particular presentation. So the question we're trying to answer at the end of the day is, what effect does a promotion have on product sales? So we model this problem as predicting the total units a particular SKU will sell in a given time period with other constraints. And in addition to that, we encode promotions as features. So which means that, if we want to try different promotion settings, we can just change these features and then you can end up with a different value, right? A different output, and then you can compare those outputs. So what, oh, sorry, I forgot to explain what a baseline is. So a baseline is effectively a scenario when no promotion is run. So typically what will happen is a category manager will run a few promotions. They'll get baselines for everything, and then they will get a promotion sales, which is effectively the number of units a product will sell when it's on a specific promotion. And then they can compare these scenarios to say, okay, in this case, looking at these two graphs, scenario 2 seems better because it looks like it'll sell 140 units versus scenario 1 sells about 120 units. And then decide to go with scenario 2 versus scenario 1. This sounds really simple. I mean, so far I haven't explained anything that's rocket science. You can build a machine learning model, you have some features, I'm perturbing the features, I'm looking at the outputs and making some decisions on the outputs. And that sounds pretty simple. And of course, if it was simple, I wouldn't be here with this talk. I'm here because there are very interesting issues with this problem, and that's what we'll try to solve. So let's go back to the one core assumption that we can have when we're trying to build a particular system like this, which is considering all things equal, we would assume that the quantity purchased varies inversely with price. And what that means is if I give a product more discount, it should sell more, right? Makes sense. Like if someone tells me that if everything else is constant, then if someone tells me that, hey, I'll give you a 60% discount versus 70% discount, probably 60% discount should sell less than a 70% discount, right? I'll be more inclined to buy something at a 70% discount. So it makes a lot of sense. And I would expect a nice kind of practically linear a line like this, an increasing line like this, where as I increase discount, I will just see an increase in sales or quantity sold. But alas, if you kind of look at the actual demand curves, that are learned by the model, it's nowhere close to these expectations. It's not the case for all SKUs, but there are a large number of SKUs where you will see things that are kind of counterintuitive. For example, if you look at this graph, you'll see that somehow giving a 20% discount is worse than giving no discount at all. And if you look at the other part, you see that somehow giving a 45% discount causes a dip versus giving a 40% discount does not. So it's kind of really strange because, this is what this is what reality should look like, but it doesn't. The reason for why this can happen is many reasons, and I've tried to list some of the important ones. The first things first is achieving this all things equal point is really hard, right? Like, for example, the ideal way to achieve it is by experimentation, where you consciously keep everything constant, vary only the promotion, and then see what happens, right? But that's really hard to achieve. It's obviously time consuming, it's expensive, and typically it's very hard to run. The second one is, of course, true demand is always changing in time. Like even if I take the exact same product, the exact same day of the week today, and then I take it next year, I'm going to see some differences. The reasons for why promotions are run and why they have certain sales patterns is not clear. For example, if you're trying to get rid of inventory in a particular store, then I may have a crazy sale. I might say 90% off. I might sell that out, and then I might do nothing else. I might never order the product again. And although it might look like we haven't sold enough, according to our numbers, it was probably a very successful promotion because they managed to sell out the inventory, and that's exactly what they intended. Another one is the opposite problem, where if I have a very strong promotion or a very popular promotion, I might sell out, and then it might take me several days to get more stock in. And during that time, I've already lost sales, right? People might come and see that there's no product. And although it looks like it has low sales, it was indeed actually a very, very popular and a very strong promotion. So, and the final reason is, in general, if you look at the universe of promotions that are run, they're typically kind of constrained in certain ways. Like 5% and 10% are very popular promotions. For example, 50% off might be a very popular promotion, but a 60% off may not be as popular. So there's also some sparsity in terms of exactly where and what types of promotions are run. But of course, if you're giving a system that where you can try out these scenarios, you can expect the end user to try many different scenarios, and they may even try 60% or 50% or 70%. You really don't want to constrain them in terms of what scenarios they can run. So ideally, we do a lot of things to kind of overcome this problem, but at the very least, one of the simple things that we'd like to do is to kind of clean up this demand curve. So we at least want to try and see if we can smooth out and remove some of these problem areas, so that we're not giving counterintuitive or weird results to the end user that might also cause them to kind of lose some confidence in our results. So we also want to make sure that we can provide them something that's reasonable, so that the results are actually useful to them. So that being said, that's where usually my real job ends as well, where I figure out, I kind of work with my team. They tell me what the problem is. We kind of discuss it, and then I throw it back to the team and say, okay, here's the problem, please solve it. And that's where Tim comes in, and he's going to explain to you how to solve this problem. It's his brainchild anyway, so I'll open it up for Tim to kind of walk us through the solution. Tim, I'm going to stop sharing, and yeah.
Cool. All right. Yeah, thanks, Kanchana. That at Kinaxis is really, there's no lack of interesting problems. So, and interesting solutions really comes from interesting problems. So here's what the problem looks like in terms of our to the user. So as you recall, like Kanchana was saying, that category managers use our products, and on the promo planning UI, this is sort of what happens. The user can change only the promotional setting and receive real-time forecasts for our ML model. So some of the problem here is like when you increase the discount or the award, the forecasted units seem to be decreasing, and that's not good, because this is exactly the all things equal scenario that is expected, and the model is not doing what makes sense in terms of economics and law of demand. And so and there are two things here that would improve the user experience, right? The first thing is monotonicity. So there is the idea, that we are obeying the law of demand. If you are increasing the discount, what should happen is that the predicted unit sold should not decrease, right? Like, it doesn't make sense if you bump the percentage off from 40 to 50%, you're gonna end up with fewer units sold. In most cases, obviously. The second part is smoothness. That was basically the idea that you shouldn't have a huge jump. When the user increases the percentage off by 1%, for example, you shouldn't be expecting units sold to jump like a 2-3 fold. So just with to get to these two desired properties, we basically just have a two-step process. The first step is to apply a isotonic regression, and the second step is a monotonic interpolator. So only two steps is pretty simple, and it's you can see this as an additive component to our ML models. We do have a big variety of we have diverse ML models, so being model agnostic is a pretty important requirement for this adjustment. So I'm going to talk about what these two components do, what these two steps do, just in general, in case it's not familiar. So the first thing is isotonic regression. It's basically the restriction of a linear regression model to a monotonic fit. So obviously you can see in piecewise, this is a piecewise constant or linear least squares fit to your data. So this would differ from a linear regression model. So the second bit is the monotonic interpolator. So once you fit pass it through like isotonic regressor, you're gonna get monotonic. You're gonna get a monotonic curve, right? But that's gonna be piecewise and it's gonna be jumpy. It's not. It doesn't fulfill the second requirement, which is smoothness. So ideally, you would want some polynomial interpolator on top of it. But if you just put in any smooth interpolator, it's not necessarily going to work. As you can see on the right plot, you can see, between 4 and 5, there was a slight dip in the cubic interpolator. Linear interpolators are fine if, they preserve monotonicity if the samples are monotonic, but higher orders, especially odd powers like cubic interpolators, they don't really work. So you do need to look for monotonic interpolators. So one of the examples here is this p-chip interpolator method. That would be a monotonic interpolator that would work. So like, yes, slight gotchas when we were trying to figure this problem out that may not be obvious at first glance. So basically, combining these two steps, this is basically the adjustment procedure. So the first step is really, we didn't talk about this, but the first step is really to identify the one driver setting. So usually in most promotions, there is one value that you'll be tweaking to that is associated with more units sold. So for example, if it's a buy X get 1 P% off, P, that would be the driver setting. So if you increase P% off, you would be expecting more units sold. And the second step is that you would apply, first of all, you would sample your model. So you would take various values of P, you're gonna change only this value. And then you're gonna run feature generation to end up to get the features that you're gonna put into model, and then you're gonna get the model output. So this is might take some time if you're on a small machine. So because you're gonna run you're gonna run the sample values of P, you're gonna run the feature generation, and you're gonna run the model predict. It might take some time, but once that is done, you can put that into the isotonic regression. And that gives you a function, a piecewise linear monotonic function. The third step is really to apply the monotonic interpolator. So recall that this function is piecewise constant, right? So we don't want all of P because otherwise this interpolator is just going to give you the same thing, which is just a piecewise constant function. We don't want that because that's not smooth. So we want the subset of P. More particularly, we select them based on whether F jumps at P. So if you're fitting the monotonic interpolator on these subset of values, you're going to end up with a smooth-looking curve, which is really nice. So that will satisfy both monotonicity and smoothness. We're going to go into how you would adjust, how you would measure the quality of these adjustments. So these two values are basically just what we're looking at. The first one is the amount that you're adjusting. So if you're adjusting a lot, that is not good because the curve that is learned by a ML model is bad. The second metric is the longest interval of driver settings, which cause no change. So basically, if you're seeing a really long and flat surface on your demand, that's not good as well, because the user is going to change the settings and see that that doesn't affect the predictions at all. So here's an example of what's good. So you see that the adjustment metric is low, it's only 3%. The flat region is pretty small, it's like 0.47. It makes sense because most promotions are between just 0 and 50% off anyway. So So that's fine. Like we're hitting most of what's reasonable. This is a bad adjustment. So you can see that the amount adjusted is a lot higher than before. 7% is a lot bigger than 3%. And non-responsive zone is a bit higher. So recall the previous one was 47 and this is 55. This is really bad because you're ending up with a curve. The learned demand curve is it doesn't make sense at all. We can see this because we can see this just from the metrics, because you can see that the amount adjusted is high, is more than 10%, is really high compared to like 7 and 3%. And the maximum the non-responsive zone is basically the entire graph. So this is bad. So what's learned is bad, but that really triggers the question, what's wrong with the data, right? Or what about the data doesn't make sense to you? So at this step, these metrics would trigger investigation. So some hypothesis that you might want to throw out is that is this product being phased out, or is the retailer starting with low discounts and then moving towards higher discounts in an effort to clear inventory? That might be what's going on, but we don't know at this point. The only thing we know is that these metrics are triggering flags. Well, lastly, I guess we can just talk about the computational cost. So as we talked about the computational cost is kind of high. So if you're looking at the example where you buy X, get 100% off, that's X can be anywhere from 1 to 10, but it's an integer, so you're going to end up with like 10 samples. But P is a float, so you have to sample that range. If you decide to sample 100 points, you're going to end up with the total number of rows is 10 times 100. That's 1,000 rows. You need to do feature generation for 1,000 rows, and you need to predict for 1,000 rows. So in a real-time context, that can give you a pretty high latency. With the adjustments that we talked about, the 2 steps, that doesn't take long, but the problem is that these adjustment steps need to wait for the prediction results, and that might take a while. So I guess the main the conclusion of this is really that it's a model agnostic adjustment procedure. If you want model, like if you know for sure you're going to use a single model, there are things you can do, like you can have model-based monotonic restrictions in gradient boosting models. There are settings you can choose. And the other piece of this is really experiments, right? Like if you're to tease out this all things equal portion, you're gonna need some causal relations. You need to say something about causality. You need to be able to randomize certain things, and that's really if you can do that, that's great. You probably don't need these adjustments. And that's it for our presentation. So these are LinkedIn's, and also we are hiring.
Yeah, we are hiring, especially the MLAS team that I talked about definitely has some positions. So yeah, take a look.
Thank you so much for your presentation. It was really, really interesting. So I see questions are starting to come, so good. I'll start reading the first one, and then you can decide which of you wants to answer. So the first question is, by promotion, do you mean price cut? For example, price was 200 and now it's 150, or promotion as a giveaway. For example, here is a $15 off of any purchase above $100. Thank you.
I think I've answered that in the chat.
Yeah. Yeah. So I think basically Tim's answer, it's all of the above. So you can run many different types of promotions, and you want to give the category manager as many options as he can possibly run. So yeah, so I think it'll be whatever, as many promotions as a particular retailer wants to run. So types of promotions.
Yeah, we represent various promotions like in a common way. So you can compare across promotions. You can compare a lot of things like marginal discounts and yeah, it gives you a common way to compare across all kinds of promotions that you might otherwise not be able to do.
Yeah. And I think Aditi's next question is, how do you make sure that not too many discounts are given away? I wonder if a customer purchasing without promotions can decrease as promotions start anticipating purchase only with promotions. Thank you. Yeah. So Aditi, it's a good question. So there are two aspects to promotion planning. So the first use case is the one that we talked about today, which is the scenario planning use case, where category managers can go in and try different promotions for their products, and then they choose. In that case, there's no way that we control how much promotions is given out. It's more of their choice of what they want to run. But we do have other use cases where, and I know I briefly touched upon the optimization use case, where we do optimize for an entire flyer, for example, where we tell you what kinds of products to put on which page on the flyer, and again, there you have additional constraints, like say how much maximum spend do they want to do for that promotion period. So that kind of caps how much discount we can give. So either way, those caps come from the client itself, where they tell us how much we can potentially promote. And your second part is, I wonder if a customer purchasing with a promotion can decrease as customers start anticipating purchase only with promotions. That can happen, and in the sense that, especially if promotions are repeated, I think if you know that milk is going to be on sale the second week, it happens. But I don't think it happens as often, or rather, let me put it the other way. It's very hard to tease that out, essentially. But it's possible. It's just not something you can right away tease out. I think the way to tease it out is by actually trying different promotions and kind of encouraging category managers, giving them more of a tool so they'll know that they can try other things and they're not limited to what they've done before or in a time period that they've done before. So no problem, Ati. Happy to answer it.
Yeah, that's a really good question, because I think this is one of the earlier slides. ML is one part of this problem. Like the model is just one part of this problem. Like there's optimization. There's how much you want, how much information do you want to give to the user, and what options the user can explore to achieve their goals, right? So sometimes if enough users have a common problem they want to solve, that becomes a feature. Otherwise, I think it's mostly about empowering the category managers, the users on the platform.
Exactly.
Any other question? Don't be shy, people. Post it in the chat. Another question.
Commerce, so much data collection. E-commerce website, many of consideration are important to apply have equivalence to the e-commerce context, because e-commerce allows for so much data collection compared to print. Do you have any advice on what to collect from e-commerce website interactions? I mean, I think especially with the e-commerce part, right now we're talking about just, overall promotion planning, but we used to have a product before called customer lifecycle management, where we did deal with a lot of, specifically e-commerce platforms and customer specific recommendations. I know e-commerce right now has moved on from customer, where during COVID, I think we've had more just general web interactions being high. I think the rule of thumb would be just, as much as possible, I guess. So definitely, I would say, obviously transactions, time of the transaction, date, all of those things play a role. What types of promotions were run plays a role. Exactly which page, a particular product existed, when a person bought it plays a role. But again, it also differs from like vertical to vertical. And because even within retailer, for example, if I go to Voila, which is Sobeys platform for online ordering, I already know what I want, and I don't browse. I generally kind of just go add things I want and then check out. Versus if I'm doing something like a clothing store, say an Old Navy online, then that changes kind of parameters that I would collect. I don't have an exact answer for it, because it just depends on the vertical. And the rule of thumb is try to get as much as you can. I mean, if your client tells you that they're going to give you 10 data sets, just say yes to all the 10.
Yeah, like unstructured data it's there's a lot of things to learn from unstructured data, and ideally you want structured data, but there are too many things show up on the web. That's another question.
Yeah, and a side thing is we've done a bit of work. Actually, we have a talk in the Canadian AI, I think in a couple of months, which I think Tim also helped co-authored along with a University of Toronto student, University of Gulf student, along with the professor. So I think we've done a lot of R&D in terms of how unstructured data can be used, and I think we had a paper even last year on that. So we've done a lot of work on that, but specifically for our use cases, we haven't had to dig as much into that space just yet. Similar to Taf's question, does model assumption make sense given that demand can be influenced by competitor discounts, etc.? Are there certain verticals that tend to be more conducive to this type of modeling? A good question, and I think it kind of boils down to what data you can collect. So if there's information that can be collected, whatever can be explained and modeled is what we can work with. So the assumption right now is if you're working with your customer's own data, then the assumption should be that as you decrease discounts, you can increase sales, right? But of course, if you can bring in competitor information into play, that could change the timeline where you're saying that, okay, because you brought in some other competitor is promoting, your sales might fall. And so hey, this might not necessarily be a great promotion, but that has to be modeled more in a more nuanced way. And frankly, we have tried customer information, but mostly from like aggregators. It doesn't work really well when it's aggregated, and I don't think any two retailers their item level data to kind of do this kind of modeling. But it's a good question, and yeah, that consideration exists. But as long as you can get those features and put them into the model.
Yeah, there's one thing about the detail regarding whether monotonicity assumption makes sense. I think it definitely makes sense in terms of like in the context of keeping things all else equal. So it doesn't really matter whether your competitor is running a discount or not. Like if you increase your discount, you shouldn't, in most cases, shouldn't be expecting units sold to decrease. It doesn't make sense.
That's true.
Yeah, so
how do you reconcile pricing strategy and promotional strategy? For example, I can price headphones at 50 discount, or I can price headphones at 60. That's a good question, but I think for many of these, so they kind of play together. So you almost computed this. So the way discounts are computed is assuming that there's a price exists and a promotion that's run on it. So together they kind of give you the value of discount. So whether you optimize prices first or promotions first is you can have them as variables and play around with them. But a lot of the times prices are usually kind of at least for a lot of our use cases are kind of in play before. And then you're almost trying to run promotions on top of it. But given the way we model promotions, I think a price with a discount, a price with the promotion kind of comes up with the representation of what a promotion feature looks like. So it's kind of in play. So if they wanted to play around with it, those options exist for them to play around with it. But typically, prices are kind of preset, and then they're trying to run promotions on top of it. But there's no reason why they couldn't change both. Good questions, by the way. Very insightful questions on the topic.
Yeah, asking these questions are really great, because when we ask these questions, right, it gives us like a greater insight into how retailers do pricing and how they do promotions. And sometimes just having this idea, insight into these process do help with ML quite a bit. So you do quite a bit of what is useful is understanding the business.
Yeah. Oh, I realized that my video isn't working. Never mind. I had this problem yesterday as well. So I turned it off and on. It doesn't work anymore. But are there any more questions we can answer?
There are no more questions, so
Okay.
maybe we can give like just 1 minute, 35 if there is like a last minute question.
Yeah.
And
Do you have
then
any
otherwise
questions for us? Like anything about Kinaxis or what we do? Not necessarily.
you can tell for sure something. It would be interesting, especially maybe about the position you're hiring. So I think people would be interested.
Oh yeah, for sure. I think so. I think we're hiring positions in multiple teams. I'll talk specifically about two teams. One's the machine learning engineering team that basically is part of our data science group, and they help us basically build all of the surrounding pipelines and infrastructure, and everything surrounding our solution is built by them. They help us kind of take our solution into production, essentially. And they're a great team to work with. We work very, very closely with them. And the other team that we're hiring for is the MLAS team, which is machine learning as a service. And I told you, I think I showed you in the diagram before, they kind of build out that platform over which we deploy our solutions. So they do everything from orchestration to scaling to managing, machine learning jobs. So they're really a fantastic team again. And, the manager there, Pablo, is a good friend, and he runs a really, really good team. So, please do apply for that position as well. We're really looking for great people, great software engineers with good skills to join us.
Okay, thank you so much for explaining that. We don't have any other questions, so I think we can close the talk here. So thank you so much to both of us. It was really an interesting talk, and really enjoyed. Thank you so much.
Thank you, and thanks to everybody for the questions. Appreciate it. Thanks, Nadia. Bye-bye.
Bye.